Okay, so let's look at some examples of finding a counterexample. So a student makes the following conjectures. Find a counterexample to disprove the student's conjectures. So the first one says, if your clothes are wet, then it is raining. Well, there are many reasons that my clothes are wet. It may not be because it started pouring outside. So an example is, or a counterexample could be, I could have fallen in the pool. That would make my clothes all wet. Plenty of other examples that you could use there. Maybe someone dumped a bucket of water on top of my head. Many counterexamples besides it was raining outside. Okay, next one. So if the name of the month starts with the letter J, then it is a summer month. So to come up with a counterexample again here, I need to find a month that starts with the letter J, but I don't want it to be a summer month. So if you think through all the months, you'll find, well, the very first one, January. So this starts with a J. So it satisfies the hypothesis. But it is a winter month. So it satisfies the hypothesis, but it doesn't lead to the conclusion, which is why it's a counterexample. Okay, next one. If a number is even, then it is divisible by 4. So this is saying all even numbers are divisible by 4. So I need to find a even number that is not divisible by 4. Well, one of the first few, you can do 6. 6 is even, but not divisible by 4. Okay, number 4, the value of x squared is always greater than the value of x. So I want to find a value of x for when I square it, it is not greater than x squared. There are a few examples you can use here. Probably the easiest one to see at first is if x equals 0. Then 0 squared is equal to 0, which is not greater than 0. Another example that would actually be less than is if x equals 1/2, then 1/2 squared is equal to 1/4, which is actually less than my original. So that's an example of it actually being less than instead of greater. Okay, go ahead and pause the video. I want you to try number 5. So there were many example or counterexamples that you could have used here. Basically, you wanted to use something that involved negative numbers, so I use -5 and -4. If I take the sum of those, I get -9, but when I take the difference, I get -1, because when I subtract a negative, it really becomes a positive. And so the sum here is definitely not greater than the difference. Okay, and then this last one, the absolute value of the sum of two numbers is equal to the sum of the two numbers. So this is saying anytime you add two numbers and take the absolute value of it, it's equal to if I just took the sum of them. Well, we know that's going to be not true for negative numbers, so let's consider -1 and -2. Well, -1 plus -2 is equal to -3. Well, and then when I do the absolute value of the sum, the absolute value of -3 is really equal to 3. And so Negative 3 does not equal to 3. So the absolute value of the sum of the two numbers does not actually equal the sum of the two numbers. So this conjecture would be false. Okay, that's it for today. If you want to look at some extra examples, those are linked below. Otherwise, you can go ahead and get started on that homework. If you have any questions, please reach out. Hope you have a great day.